Hey everyone, welcome to the Weekly Space Hangout. My name is Fraser, Cain, and I'm the publisher of Universe Today, and it is Friday, October 9th, 2015. This week, we're going to be talking about Pluto's atmosphere, weighing neutron stars. The Nobel Prize in Physics was awarded. Scientists could be wasting their time. Are scientists wasting their time? First private mission to the moon, Orbital Sciences Rebuilt, the 20th anniversary of Exoplanets, and the effort to digitize Apollo pictures. Joining us this week, no special guest, but we've got a special panel just for you. We've got Dr. Brian Koberlein.
Hi.
Koberlein. We've got Kim Cartier. Hello, Kimberly.
Hello.
Welcome back. Look at that. You've blacked out your window over on the left-hand side so that now you're not backlit. That's fantastic. Congratulations. We got Morgan Renberg. Hey, Morgan.
Hey, Fraser.
And we've got, last but not least, we got Dr. Paul Sutter.
Hey.
Hey, Paul. How's it going?
Pretty awesome. How are you?
It is also awesome. I'm sure we didn't mention. Didn't I watch The Martian on Friday last week? Maybe not. And then I hadn't talked about The Martian. Anyway.
I still haven't seen it.
I saw it.
I'm going to see it tonight.
It was.
Twice.
You've already seen it twice. Yeah.
Twice.
Yeah. It's fantastic. So if you haven't seen The Martian yet, and you haven't read the book,
You can do both those things today
right
still.
now and just go do those things. Yeah. Yeah. Take a sick day off work. Go watch the movie. So let's get cracking. Well, actually, before we get cracking, I just want to remind everybody this is a live, interactive experience. You can talk to us. We will talk to you. And the way you do that is through the Q&A app, which is wherever you're watching this video, there's like a link that says that we're interacting with the public. You can click that. You get another video screen pop up. You can still watch the video, but then there's a bunch of questions over on the side. And so just to demonstrate the awesome power of this, I'm going to say hi to Tony Lynch and Yov Landsman and Matt Woods, Tom Nathy, Jim Meeker, Nancy Graziano, Ilad Avron, Marcel Bacher, Matt Woods, Richard Strassel, Ben Kalo, Jack Kulk, Rick Schwartz, Bert Wolters, Andrew Planet, Guido Bibra, Thomas Traniker, and Linda Sadek, and Seb Dust Bunny. Right on. Okay. Those are the people who are watching right now, as well as all the rest of you who couldn't be bothered to log into the Q&A app, but I don't blame you. Actually, I've got one other piece of sort of administrivia here that we need your help with, which is that if you go to iTunes and you search for the Weekly Space Hangout, there's a sad and depressing lack of any kind of ratings and positive comments. There's like one comment from like some grumpy guy about how I talk too much and I never listen, and that just pops up to the top, and nobody's going to download and listen to it.
I'm sorry I wrote that. I'll delete that.
Would you? That's the least you can do, Paul.
He's not wrong.
I know he's not wrong. But what we need you to do, like, especially if you're like one of the podcast listeners, is could you take a second of your time, go to iTunes and leave us a 5-star rating and a really nice review so people can know that, yes, indeed, this is a highly valuable, well-organized, smooth roundup of all the big space and astronomy news of the week. And that would mean a tremendous amount to us and help other people find the show and like it. And the more people who listen to the show, the more we can do this, or as opposed to just feeling sad and not maintaining it. So anyway, just take a second and give us a rating, and that would mean a lot. All right, let's get on with the stories this week. So first, let's talk about Pluto's atmosphere.
Great. So, if you all remember from a few weeks ago, there was this amazing image that came up from Pluto, from New Horizons, that was downloaded that showed Pluto backlit. So you had those New Horizons after the flyby looking back at Pluto, and the sun was in the background, and you just saw this amazing halo glow of haze around Pluto itself. And that image, it was phenomenal. It got astronomers talking about, what could be causing this haze, what molecules, what's the scale height we're looking at, what's going on here. And there was a new image of the same backlit Pluto released this week that showed that same haze in true color. And I'm going to see if I can screen share this to you so that you guys can see. And here it is, Pluto backlit in true color. and you can see that the haze actually glows blue, which is pretty phenomenal. I'm super excited about this. So Pluto has a blue, hazy atmosphere, and the fact that it's blue actually tells us a lot about what kind of molecules could be causing this, because it's a very similar effect as to why the Earth's sky looks blue, is that you have molecules of a certain size, very, very small, that are scattering light around the atmosphere. And so this tells us that the molecules that are in Pluto's hazy atmosphere must be of a similar scale as to the same molecules in the Earth's atmosphere. Now, in Earth's atmosphere, that's molecular nitrogen. In Pluto's atmosphere, it's probably not molecular nitrogen, but it tells us that these must be really small particles that are being bounced up into Pluto's atmosphere. So that's a really exciting thing.
They're most likely tholins.
Tholins, yes. I don't know much about tholins.
They made this web, and that trapped the Enterprise. Can you explain that, Brian?
Different kind. The tholins in this case are large molecular molecules. They're organic molecules that are formed when ultraviolet light hits things like nitrogen and ammonia and things like that, and they make these large molecules. It's what gives Pluto its reddish color as well. Titan's atmosphere has a similar effect because of tholins in its atmosphere.
It's amazing, though, that before New Horizons passed, the question was does it have an atmosphere? How thick is the atmosphere? And now there's, we have these pictures of it and a really good understanding of what the composition is, and it's just going to get better and better. Again, it's like another reason that we need to send spacecraft to other worlds.
Oh yeah. And so it's great. And so it's great. Every week we're getting something really new and exciting about Pluto, and it'll be this way for the next year and a half.
Yeah.
So that's really great.
Yeah, I still think it's terrific how, or it's not terrific, but I mean the fact that the data transfer is so low that the news is still going to trickle back. Even though it's this one flyby, they took a tremendous amount of science, the news is still going to trickle back over the next, 16 months as we wait for all the information.
Right.
Brian, how much does a neutron star weigh, and how do you know?
Well, this is a new method. What's interesting is we know how to measure stars if they are binary stars, for example. If we know that they're orbiting another star, we can use Kepler's laws to calculate what the mass is. What we can't do as easily is determine what the mass of a star is if it's by itself. There are some things we can do with regular main sequence stars and look at its temperature and its color and things like that. But with neutron stars, if there's a neutron star by itself, it's really difficult to figure out what its mass is. Well, there's this new research that came out that looked at pulsars, but two pulsars in particular. And what they did was they looked at the pulses of light. Basically, a pulsar is rotating very quickly, and as it does, its strong magnetic field creates these kind of beams of radio energy, and we hear those as short pulses. We can actually use those to measure the timing of its rotation very, very accurately. And one of the things we've noticed with a lot of pulsars is every now and then the timing will glitch. So they'll gradually slow down as energy is radiated away from them, but then every now and then they'll glitch and they'll speed up in just a little tiny amount of, like a fraction of a second, they'll be faster, and then they'll start getting slower again. These glitches are basically due to the fact that the interior of the neutron star is a superfluid. It's basically the superfluid of neutrons, and so as the neutron star slows down, it's really the crust, the outer layer, that's slowing down and not the core. And then eventually what happens is there's this interaction between the core and the crust that causes this kind of transfer some of the energy, and they glitch. Well, the pattern of glitch depends upon the details of the interaction between the interior and the crust. And there are different models that have been proposed, and what this new research did was they looked at the Vela pulsar, 45 years of data of the Vela pulsar, and they looked at the pattern of glitches, how big they were, how often they occurred, and they compared them with different models. And what they found was there was only one model that worked. And they did this with another pulsar, and the same model worked. So it looks like they have now a detailed understanding of what that superfluid core is. What's interesting, though, is that you can use that if you know because it has to be a superfluid, the interior has to be cooled to a certain level in order to be a superfluid. And if you know how old it is, you know, since neutron stars tend to start at the same temperature, you know what its kind of upper level of temperature is. So if the core has become a superfluid, you know basically how big it is, because a larger neutron star will cool more slowly than a small one. And so using the age, the surface temperature, something like that, and the fact that they're superfluids, they actually were able to calculate what the mass was. And they found one was about 1.5, I think the Vela pulsar was about 1.5, 1.6 solar masses, and the second one that they did that has some weird numerical name was about 1.8 solar masses.
What's the upper bound of a neutron star? How heavy can they get?
About 2 solar masses, I think.
And then beyond that, they turn into black holes?
Basically, yeah.
That's really cool.
So someone once told me that a spoonful of a neutron star weighs as much as Mount Everest. Is that true?
That seems like the right order of magnitude, yeah.
Yeah, neutron star is basically a city-sized atomic nucleus.
Yeah.
Someone asked me a question about what color they would be.
Probably white hot.
Yeah,
They
but
but
what if they had cooled down?
Well, they would be very dark, I think. I mean, their gravitation is very strong, so if they were cooled to some quote-unquote reasonable temperature, they would be extraordinarily dark.
Cool. That's all. Just wanted to know.
Okay.
The people asked the question, and I just need to bring it along. I can do a whole video on this now. Thank you, Brian.
Checks in the mail, right?
Yeah. So let's move on to the Nobel Prize in Physics.
Yay, yeah, it's always exciting when the Nobel Prize goes to something astronomy related. And this year the prize was awarded to a solution to a long-standing problem in astronomy, which was called the solar neutrino problem. Basically, a neutrino, by the way, you are swimming in neutrinos, literally. There's something like 1 trillion neutrinos passing through your eyeball every single second. They just flood the universe, but they're very, very tiny, and they're electrically neutral, so they hardly ever interact with normal matter, with us. And neutrinos are created in various nuclear processes, like in the nuclear fusion in the core of our sun. And so there is these very sophisticated models of the nuclear processes in our sun that predicted a certain number of neutrinos that would be made. But then when observers built these incredibly huge detectors, giant tanks of water to capture stray neutrinos every once in a while, they only saw like around 1/3 to a half of the number of neutrinos that they were expecting. And so in true physicist fashion, the observers said the theorists were wrong, and the theorists said the observers were wrong. And this kind of stayed this way for a couple of decades. But it turns out that everybody's right, that the theorists were correct in their calculations and the observers were correct in their observations, but neutrinos were doing something a little bit funky. So like when you think of an electron, you create an electron and it travels around, and then later on you can go check out that electron and it's still an electron, right? And this seems obvious. And if you create one kind of neutrino, you expect that when you create that neutrino and then you check on it later, like when it hits the Earth, it'll be the same kind of neutrino. But it turns out that neutrinos aren't really just one thing. When you create a neutrino, it's actually a mixture of all 3 kinds of neutrinos, and as the neutrino travels through space, it kind of changes its identity. What's called oscillation. It like moves back and forth. Sometimes it's one kind of neutrino, and then moves ahead a little bit, and now it's another kind of neutrino, and on and on. So what was happening is the neutrinos that are made in the sun are one kind, and the detectors on Earth were originally built to detect that kind. but on their way from the sun to the Earth, they would change into other kinds of neutrinos, and so our detectors just wouldn't see them. And so this Nobel Prize was awarded to two groups who, when you put their results together, kind of solve this problem, showing that neutrinos do change their flavor, change their state as they move around, and that if you add up all the kinds of neutrinos that come from the sun, you get the right prediction, or you match the predictions that what the theorists said for the total number of neutrinos produced in the sun, and there you go, Nobel Prize.
It's funny how there's such a delay when we hear about these kinds of discoveries. You know, when did they have pretty good confirmation that this was happening? 10 years ago? 15 years ago? I'm trying to think how long ago it was.
Yeah, so it was around the turn of the century when these results first started to come in for this demonstrating this effect of neutrino oscillation. This is actually, I think, the fourth Nobel Prize related to neutrinos. One for their initial discovery. There was another one for the discovery of cosmic neutrinos. This one for the neutrino oscillation. I mean, Nobel Prizes, you can't exactly take them back. So you gotta be really sure that.
Really sure, yeah.
Really, really, really sure. But on the flip side, Nobel Prizes aren't awarded to people who have died. So if someone's getting up in age and they've done something major, sometimes you get slipped a Nobel Prize, maybe a little bit early.
Right. So got to be sure, but not too sure.
Exactly.
Awesome. Okay, well, let's move on. So let's talk about the first private mission to the moon.
Yeah, so over the last few years, Google has been sponsoring a competition called the Google Lunar XPrize to send a privately funded, privately developed mission to the surface of the moon. And in order to win this, you have to land on the moon with a rover, drive 500 meters, return some sort of HD video and imagery to the Earth, and you have a short window in time in which you actually, once you've landed, you have 24 hours or some short period of time in order to actually accomplish all of these tasks. And it was supposed to end, I think, last year, and nobody had developed sufficiently to be prepared to send, so they've extended the deadline through 2017, but you have to commit to launching, as in sign a launch contract by the end of 2016. And we now, at the end of 2015, have the first of those launch contracts signed by an Israeli nonprofit group called Space, I don't know if it's Space IL or Space IL, but they've developed a rover that they think will be the first to rove on the surface of the moon since the Apollo astronauts left, or I guess actually the Chinese have roved on the moon since then. But so we've had three countries, China, the United States, and the Soviet Union, land onto the surface of the moon in some sort of non-destructive way. And we're hoping to add more people and more countries going forward. And so they've signed a deal with a launch vehicle provider here in the United States to send that near the end of 2017. Now, if they're successful, they'll reap $20 million from Google, but that will only offset a portion of the development and launch costs necessary. And so Google isn't here making this, a freebie. It's still going to be a lot of sunk cost. But if you can go to the moon as a private entity and perform there, then you have a lot of opportunities. Whether it's licensing the video that you take from the surface of the moon, or providing your technologies for future development on the moon, etc. And so we're one more step closer to sort of realizing this 21st century dream of having space not just be the realm of superpowers and other large nations.
One of the things that's kind of interesting about this as well is that some of these teams are looking to actually share a launch vehicle. So, to save costs, they're looking to, perhaps a whole bunch of them are going to buy a SpaceX launch, for example. And the kind of interesting thing about that is then you might very well get a race across the moon, so that all these vehicles are all going to land on the moon at the same time with the same landing vehicle, and then they're all going to try and race across the moon, and whichever one will do it. So that'll sort of add to the tension and excitement, I think.
Yeah, you could imagine that turning into a really sort of popular culture event here. To spend the day watching a car race on the surface of the moon is just tantalizing.
Yeah, I like that idea. So when does this prize wrap up? Like, when have they got to finish this?
It's got to be completely finished under the current schedule by the end of 2017. So that means they've launched, they've traveled, they've landed, and they've roved all by the end of 2017. But Google's eliminating from the competition, at least under their current rules, anybody who hasn't signed a launch deal by the end of 2016. And so originally this was supposed to have already ended, but there were many groups that had made substantial progress but weren't yet ready to just sign a launch deal. And so Google has already at least one time extended the course of this prize. But now that we have at least one competitor who's met their criteria, I would say it's unlikely that we'd see another extension, and that we're looking at less than 2 years probably now until we see, hopefully, the first privately funded trip to the moon.
And I always have to disclaim that I work for HeroX, which is a spin-off of the XPrize, and so Morgan was not paid to talk about the XPrize, the Lunar XPrize, in any way.
Well, I would take money.
He would have if I'd offered.
HeroX, I will take your money to talk about.
That deal would have come together. Yeah. So we've got a couple of questions. I thought, I'll do something really different and actually pose people's questions to the audience. So because we've got a little time to spare, so let's do that. So Elad Avron asks, and this is sort of back on the Pluto skies question, if we sent a robot to the surface of Pluto, would the skies be blue?
So the answer, I believe, is yes. So it's not just the fact that we were looking at the haze of Pluto's atmosphere as it was occulting the sun, but if you were on the surface of Pluto looking upwards, you would still be able to see part of that blue light scattered around the atmosphere, however thin it is. Just like when you're standing on the surface of Earth, you can see the blue light scattered throughout the sky. It might be a bit thinner and a bit more difficult to detect the blue itself, but the blue would be there.
Yeah, I think Kevin might be right from a technical standpoint, but I think I'm going to disagree from a practical standpoint. The atmosphere of Mars is relatively faint as seen by a rover like Curiosity, and it's thousands, if not millions, of times denser than what we have at Pluto. And so there would be blue photons hitting you, but I don't know if you or your rover would be able to perceive an actual blue color.
As a counterpoint, you're right, it's not very dense, but isn't it also much, much thicker? And so you'd have a lot of opportunities for scattering light from the sun. So that might work in your favor to maybe make it slightly bluish.
All right, you know what? This sounds like a blog article. Someone's going to have to write something. So we have to sit down.
Someone has to do some math.
Yeah, there's going to be some math involved.
Depends on the size of the molecules.
Size of the Tholians. All right, let's move on to the next question here. So this one comes from Andrew Planet. Neutron stars have high energy jets like black holes. Does that mean they also have accretion disks?
They can. Yes, you can have material accreting around a neutron star. That would be an accretion disk. They do have strong gravities. They do have strong magnetic fields. So you get similar things, but it's not at the same level.
But you could get an accretion disk around the Earth, right? Like if we had a moon and it got below the Roche limit and got torn apart, then it would end up with a ring, and we would call that an accretion disk.
Right. Well, there are also things called microquasars that are star-sized objects like neutron stars, maybe white dwarfs, that behave similarly, and that they might have an accretion disk, but they have jets, and we can study those to look at the long-term evolution of real quasars.
Okay, moving on. Where did my questions go? Okay, here's a good one. So Samir Ranjan asks, and I'll throw this one back at you. Actually, I'll throw this one at Paul. How does a binary star system work?
It works just like a planet around a sun works. Gravity. Gravity is my answer.
Final answer?
Final answer, gravity.
Awesome. All right, and I got one more here, and I'm going to throw this one at Morgan. Jack Kolk asks, what's wrong with children going to space?
Is there something wrong with children going to space?
Well, I guess that's the first question. Is there any problem with children going to space? I can imagine perhaps like the low gravity, the microgravity, causing a problem to
right.
growing
I don't think you would want
children.
to send someone whose bones were still developing into space, because astronauts experience a lot of issues develop even after they've fully developed, things like low bone density and changing shapes for their eyes, as well as certainly absorbing a lot of radiation. And once our bones are rigid and our eyes have taken their sort of final form, I think there's not much that can be done. But for a child who is presumably still, getting bigger and undergoing a lot of physiological changes, probably introducing any more variation to that is probably not the greatest idea in the world.
Yeah. Plus, they have to go to the bathroom just an hour after you launch.
I would love to know the root of that question, though.
And they get bored of...
This would not be an issue. If this question was about, for example, commercial space tourism, this wouldn't be an issue if you were flying aboard, say, Virgin or something like that, where you're spending too little time in space to have any lasting impact. You'll certainly absorb more radiation, but many of us will absorb plenty of radiation flying in airplanes, getting chest x-rays, etc., over the course of our lives.
Mm-hmm.
I think perhaps this question comes into play when you're talking about sending a colony of people to another planet. So if you're going to be spending, a year or two or decades traveling to another planet to settle a colony, you would want to send a younger generation who by the time they got there wouldn't be elderly and could not help set up the colony. Or if you're spending a generation traveling to a future space colony somewhere, there would naturally be children traveling in space. So
you could mitigate, I think, a lot of those things. If you rotationally spun your spacecraft,
artificial gravity of some sort.
Gravity, and if you're traveling interstellarly, you're going to need to bring a lot of water with you, and water actually makes for an excellent radiation shield. And so, in sort of that long-term vision of human exploration, I think that these are solvable problems. But I wouldn't, ship your baby to the ISS or anything like that.
Okay, let's move on. So this question comes from Bert Wolters. Is there any more information on advanced LIGO and its chance to see gravitational waves? Anyone following advanced LIGO? Paul, Brian, either one?
Yeah, LIGO, or advanced LIGO, I think just turned on recently, and there were some rumors swirling around a little bit that they may announce a detection, but I think those rumors went away pretty quickly. But advanced LIGO does have... Yeah. There were some... advanced LIGO does have the sensitivity to get a detection for certain kinds of signals. It's really now a waiting game. Like, they have the required sensitivity. We know the frequency of the expected signals. You just got to sit on the detector and wait.
Yep. I concur.
Brian concurs. All right. Alexander Howlett wants to know, when will NASA know what the surface features on Ceres are? Morgan, when are we going to know what those white spots are?
Well, so we may never know, and that's, the scary question whenever we have space exploration, is it could be that no matter how close we get, these features remain too bright for us to really resolve in any meaningful way. But that being said, Dawn continues to lower its orbit. It's doing this sort of stair-step maneuver where it goes to an orbit, it spends some time mapping in that orbit to plan, both to plan the next maneuver and to generate useful data for scientific observations, because zooming in to the fullest amount isn't always the best thing to do. And so they're taking sort of a slow, measured approach and taking wide-angle imagery. Now they're onto medium-angle imagery. And soon they'll be lowering their orbit down to as close as they intend to go to the surface, and starting a much slower and more laborious process of doing high-resolution narrow field imagery. And so when that occurs, we'll have a real sense of whether or not this is going to be achievable with Dawn as it's planned. And then once it's carried out its full planned scientific inquiries, there's the opportunity then to sort of get bonus science, which can then, you can put your spacecraft at more risk, you can expend additional fuel, things like that. And if this measured approach determines that these spots on Ceres are the most interesting scientific investigation to carry out, then we can devise a plan that has the best chance of telling us what they are.
Right, so they could come up with some kind of elliptical orbit or something like that where the spacecraft gets really close to the white spots and then books it back out away and hopefully, or one final suicide maneuver where it just...
Like Messenger, if you're willing to sacrifice at the end, you can grab some otherwise unattainable images and send them back before you go bang.
Right, you hard land on the surface of Ceres.
Yeah, inadvisable.
Yeah. All right. Well, let's move on to some of the additional news that we've got here. All right, Paul, we're going to come back to you and ask you: are scientists wasting their time, and how are they wasting their time?
Yes, they are. Final answer. I suppose. Okay, but they're wasting their time in a way that may not be obvious. Not just doing stupid experiments, but the total population of scientists over the past 2 decades has increased, but the total amount of funding available to do science has either stayed the same or gone down in inflation-adjusted dollars. So there's more people fighting over a smaller pie, and in order to get that money, scientists has to write grant proposals and propose what they want to work on. And grant proposals don't just come out of thin air. It takes time and effort to write those things. You have to do a lot of planning and organization. You have to lay out your case. You have to do some preliminary studies. And so the more time you spend writing grants, the less time you have to actually do science. And there's actually a tipping point in the acceptance rate, the percentage of grant proposals that are actually accepted. If something around like less than 6% of grants proposals are accepted, then more time is spent writing grants than is writing papers, and actually effectively science collapses. And we're actually very close to that tipping point right now. Overall, across all of astronomy and astrophysics, it's around 20% acceptance rate. But for new professors, young scientists who are just getting into the field, their acceptance rate is around 6%. Because there's a bias towards more senior people who have already good track records. And so for young scientists entering the field, they're actually not getting any science done. They're spending all their time fighting over grants. It's like jackals fighting over a carcass. If you spend too much time fighting the other jackals, you don't actually get to eat the carcass.
Yeah, and if you were here last week, you recall that Dr. Pamela Gay mentioned that we have gotten funding for a lot of our activities on CosmoQuest. Pamela spent months working on that grant, and that's just one grant. She's worked on a whole pile of other grants as well. She spends a huge chunk of her time just writing grants, and in this case she doesn't even know how much money the grant is going to be for that's been awarded, how long it's going to last. She doesn't know who she can hire, all of that kind of stuff. As a person who doesn't have to do that, I just sort of go like, I'm going to do this now, and then I just get to do it. It must be incredibly frustrating and demoralizing to sort of think about, like, I've got a good idea, but now I got to write a grant proposal, and then the amount of effort and time. And then if you don't get that grant proposal through for whatever reason, sometimes like politics and all kinds of other reasons that are totally outside of your control, it's got to be a killer to the enthusiasm of scientists out there.
Yeah, I've actually sat on grant committees, and proposals get rejected because someone says, I don't like that guy's face. Or dumb reasons like
I think we just lost him. Oh, it was going to be so good. What he was about to say. All right, well, let's move on, and then maybe when he comes back, we'll ask him to take another crack at it. So let's talk about Orbital Rebuilt after its disaster last year.
That's right. So if you remember back almost exactly a year ago, and I remember this because Sandy was sitting dressed like a zombie or a cat or something for Halloween. Orbital was launching their capsule to resupply the International Space Station when their rocket, the Antares, blew up basically right on the launch pad. And they were launching not out of Cape Canaveral in Florida, and not out of Vandenberg Air Force Base in California, but out of a lesser-known and lesser-used NASA launch facility called Wallops Island, which is off the coast of Virginia. Now, as you can imagine, a rocket full of rocket fuel blowing up is basically like a giant bomb, and it does a lot of damage to the pad surrounding it. Now, unfortunately for NASA and for Orbital, they hadn't paid the insurance check to insure Wallops Island at the time of this launch. And so in light of that, and in light of their failure, Orbital agreed to foot the bill for rebuilding the Wallops Island launch facility, as well as insuring it for all future launches. And that process has now been completed. And fortunately, the sort of most expensive, most vital parts of the launch facility were spared major damage. And so they were mostly making sure that everything still had its full integrity and touching up the paint and doing all of these various things. But it's a process that, in addition to the accident investigation, took a month to undertake. A year to undertake. And so now that that's completed, they can start getting back into their launch schedule. And so they haven't yet scheduled a launch for their new sort of partially redesigned launch vehicle, but they have scheduled a launch for their capsule, the Cygnus capsule, with on top of an Atlas V. And so they plan to launch using a ULA Atlas V to fulfill their contract with NASA to deliver supplies to the International Space Station. And sort of in the midst of all of this, NASA was supposed to be reoffering contracts for this commercial resupply program. But in light of both Orbital and SpaceX's accidents in the last 12 months, they've postponed that, I think, until at least the end of this year to allow both companies to fully undergo their accident investigations and provide a path forward for resuming these important tasks.
I mean, sort of the analysis after the explosion itself was this was a possible company killer. You know, that there was a pretty rough impact on Orbital, and it, you know, as well as like the decision, the kind of rocket engines that they were using. They were using these imported Russian rocket engines, and they, you know, and that sort of accelerated their switch to, as you mentioned, more U.S.-built systems. So, what impact has the disaster had on the company and sort of their ability to move forward?
So I don't think we really have a full picture of sort of the financial underpinnings of Orbital, but certainly this has put off, as it has for SpaceX, their entire launch schedule for, you know, what is now going on a year in the case of Orbital. And for a company that, you know, is in the business of building really expensive machines to then collect very large fees from people for launching that, having a year without any of that income is a substantial blow. And I think the real moment of truth here is going to come with getting a launch back to the ISS and finding out whether or not they have been renewed for NASA's commercial supply missions, because that's an important and large injection of money into these private companies, and their future may well hinge on whether they can convince NASA to believe them that they've fixed this problem and that their, you know, probability of a successful launch is just as high or higher than it was prior to this accident.
Yeah, and as you said, right, with the recent SpaceX disaster as well, I guess launch failure, you know, this is impacting everybody. Once again, space is hard.
Space is very difficult, and it turns out that no company is immune from mistakes and from accidents, especially early in the development process of this kind of hardware. The Atlas V, launched by United Launch Alliance, has a virtually flawless launch record over the last several decades. But that built on decades of blowing up rockets from both Boeing and Lockheed Martin as they sort of got their feet under them developing as well. And so this is the value in having multiple companies capable of launching to space. Is there's always going to be problems somewhere in your process, and you want to make sure that you have alternative capabilities available.
Yeah, that slow, methodical, expensive method isn't looking like such a bad idea anymore, now that you see all of the more expensive alternatives exploding on the launch pad and veering off course. Let us move on, and let's talk about the 20th anniversary of exoplanets.
Yes, happy anniversary, Exoplanets. It has been 20 years since the discovery and verification of the first exoplanet around a Sun-like star, 51 Pegasi b. So that was 20 years ago, earlier this week, to the day.
And what was 51 Peg, if people want to sort of, reminisce about that exoplanet in the days of yore?
So 51 Peg was the first of a completely unknown class of planets called a hot Jupiter, which is a gas giant planet just like Jupiter, but that orbits extremely close to its host star. 51 Peg orbits its star in just 4 days. So that was 4 days, not 4 years. And so that's well inside the orbit of Mercury, and it was completely unknown and unexpected discovery at the time. We previously only thought that exoplanets, and especially gas giant planets, could orbit only at distances outside the ice line of a star, where we see our own gas giant and ice giant planets. And then along comes 51 Peg, orbiting well inside the ice line. And we went, that's interesting. I wonder how that happens. And we're sort of still scratching our heads at that today, even though we've found that hot Jupiters are actually pretty common in terms of the type of exoplanets that we see. That may actually just be a detection bias because our instruments are more sensitive towards finding hot Jupiter planets because they produce relatively large signals in both transit observations and radial velocities. But we still find a good fraction of exoplanets that we have found have been hot Jupiters, and 51 Peg was the first of those.
Morgan is sharing a great graphic showing the number of planetary discoveries over these 20 years.
That is a fantastic plot.
Look at 2014.
2014, that was a massive data release from the Kepler team, hence why it is all green and transity. So that was a massive data crunch that they did last year as a release. So I like to show that plot too and say this is one of the reasons why we're still talking about Kepler so many years later.
If only it had more gyros.
If only. But yeah, all the way on the left-hand side of the plot, not all the way on the left-hand side, mind you, and under 1995, that one singular little red blip that's barely visible, that's 51 Peg. There are a few planets that were technically discovered before 51 Peg, but 51 Peg gets a lot of the credit, mostly because it was the first planet that was confirmed around a Sun-like star, as opposed to previously discovered planets such as the pulsar planets, which were in 1992, and 2 other very large gassy planets in 1989, and there's actually one that was discovered in 1988, but not confirmed until many years later. And those actually might be so big that they could be brown dwarfs instead of planets. So,
what do you think this plot is going to look like in the upcoming years? I mean, we got that massive release of data from Kepler, which caused that huge spike, but even the underlying, we'll go back to Morgan's picture, you can see that even the underlying radial velocity measurements are still really high as well, and a lot of discoveries are happening. So are we going to have, these numbers keep going up, especially with some of the new missions?
I think we'll definitely keep seeing the numbers going up. There'll be a little bit of fluctuation, perhaps a bit of a gap between that big 2014 spike and the next spike. But the TESS exoplanet survey is going to be going up soon. Gaia is already up there taking astrometric measurements, and it's anticipated to discover many hundreds of exoplanets itself. So there might be a little bit of a gap, but the overall number is just going to keep going up and up. And there are still thousands of Kepler planet candidates that have yet to be confirmed, and that'll just take time and computer power.
Yeah, and there's also a few ground-based surveys that are gearing up that will get a lot more exoplanets. And there's also
like
W
APS.
First.
Yeah, W First.
That's going to be lensing to get a lot. So yeah, there might be a plateau for a few years, but then it get huge.
Yeah,
right.
once you've got like the 30-meter telescopes participating in the search as well, it's going to get even better.
Yeah.
Awesome. Okay, so
it's been an exciting 20 years.
Brian Koberlein, if we landed on the moon, why are there no pictures?
Well, there were pictures. The interesting thing is, when we landed on the moon, we didn't have digital cameras, so they were still using film cameras in order to take these pictures. And there have been pictures that have been released, and they've been released on, some of them have been digitized and put on DVDs and stuff. But there hasn't been a big repository of the kind of Apollo mission pictures scanned in high resolution and unmanipulated. And recently somebody took that on themselves and started what's known as the Project Apollo Archive. And what they've got is high resolution scans up on Flickr. And you can go to the Project Apollo Archive and you can see all of these pictures that were taken during the Apollo mission. And for me, what struck me as interesting is, because they're film, because they're kind of old and aged, they have this look of the kind of travel vacation pictures that your parents or grandparents would have, and so they have that kind of candid feel of, look, we're here on the moon, and this is me standing next to the American flag.
I don't think you can emphasize enough what sort of a brilliant stroke it was for NASA to decide to send incredibly high-quality cameras to space, because the Soviet Union didn't do that. And if NASA doesn't do that on Mercury and Apollo and Gemini going forward, there's a good chance that we're not sitting here talking about space right now, because our relationship with space would be so different if you look at the sorts of pictures that the Soviets elected were sufficient to prove that they had been there. And I think NASA deserves a tremendous amount of lasting credit for making that decision that didn't need to happen back in the 1950s and 60s.
Right. There's a great manual for the astronauts, and I lost the link to it, but the astronauts had, as you said, NASA provided the astronauts with these really high quality Hasselblad cameras, which are a very fancy, very expensive kind of camera. They hardened them for space, and they gave the astronauts really good instructions on how to take great pictures in space. And so exactly that there's just this wonderful archive of all these great pictures. And so what's that URL again, if people want to go and find these pictures and look through them and prove themselves? It's flickr.com/photos and then /Project Apollo Archive, all one word. Right. Or I guess if you just search Google for Project Apollo Archive, you'll see them. Archive, and it'll be up on Flickr. And were there a lot of pictures in there that you had never seen? Like, was there stuff there that you just like, wow, that's... Because we've all seen the same pictures quite a bit, right? Yeah, you see some of the pictures, but usually you just see the famous ones. You see like the popular top 10, and this is over 10,000 pictures taken during the Apollo mission, and they're all in the public domain. They're all there for anyone to use and do whatever they want with them. And if you just start kind of going through them, it really is kind of an interesting effect, is to see not only just the important pictures that they took, but some of the casual pictures of the astronauts, and something where they saw light glinting off something and thought that was interesting. Space selfies. Space selfies. Okay, well, I think we can wrap this up. We're sort of reaching the end of our hour, so I'd like to give everyone an opportunity to let people know where they can find more about them. We'll start with you, Brian. Where do people find out more?
You can find me on Google+. You can just Google my name. You can find me on Twitter at Brian Koberlein or my website, briankoberlein.com. You can find me on Forbes. Just look for Brian Koberlein. And you can support me on Patreon if you go to patreon.com/Brian Koberlein. And if you get me to 500, I have to start making videos. So,
well, come on, everybody, get him to $500. And how is the podcast going?
Podcast is going very well. We have a new one coming up tomorrow. So tomorrow morning we'll have on the science of online dating.
Very astronomical topic. All right, Kimberly, where can people find out more?
You can also find me on Google Plus by looking at my name. You can go to Twitter, and my handle is at AstroKimCartier, and I have a new domain website, which is KimberlyCartier.org. I will also be at the Science Writers Conference this weekend, so if you're there, come find me and say hello.
Fantastic. Morgan.
Yeah, you can find me on Twitter at Morgan Renberg. Check out my website, morganrenberg.com, where you can see some of the latest stuff I've been working on, like this Space Selfies themed show that's right above me right now, and lots of other good stuff as well.
Is that the next planetarium show?
Oh, that one's already happened, but we're working on some new ones as well. You can find that one up on the website.
What's the new one going to be?
The next one is going to be called The Stories in Our Stars, and it's looking at how we've actually usefully used constellations and the stars throughout the course of the very long relationship that humans have with the night sky.
And so as opposed to the uselessly with astrology.
Yeah, as opposed to the uselessly, or today we have these 87 defined constellations that really don't serve any particular purpose. But that wasn't the case even a very recent time ago.
That sounds really cool. And where, if people want to watch that, right there, it's in Boulder. It's at the
Fisk Planetarium in Boulder, so easy drive from Boulder or Denver. And I'm actually not the person who will be giving that talk, but I'm the producer on that show, and we will be putting together a great presentation for everyone.
That's terrific. All right, Paul, where do people find out more?
Yeah, sorry I got cut off earlier. The astronomy Illuminati tried to take me down from revealing the inner workings of the system, but I fought
you were
them.
talking about money and funding, and you can't do that.
Can't do that. Yeah, so you can find me on Twitter at Paul Matt Sutter. You can also see my website, pmsutter.com. That has links to all my podcasts and my writings on space.com. That's the hub for everything. And can I plug the symposium?
Yeah, let's do it.
Oh, yeah, so we have a very special guest coming to Columbus, Ohio, next Wednesday. Ty Owen of the COSI Planetarium and some guy named Fraser Cain is also coming to town. I heard he's pretty interesting and good with crowds, along with Pamela Gay, along with former astronaut Ron Sega. We're having a seminar, or a symposium, free and open to the public. So if you live in Columbus, come to OSU Wednesday, 7 p.m. on October 14th. And if you don't live in Columbus, Ohio, it's going to be live streamed. Go to the address go.osu.edu/nextfrontiers, and that will take you right to the YouTube live stream.
And this is all free?
It's all free all the time.
Right on. And what if I wanted to ask an astronomer something?
So if you have questions about space, you can go to askaspaceman.com or just send me a question on Twitter, and I'll pick questions to answer on my podcast.
Awesome. So once again, Fraser Cain, you can follow me on Twitter, fcain. We're actually just about to go shoot video now, our next 8 episodes. We're going to talk about the black hole information paradox. We're going to be talking about how long a day is on Earth and why red dwarfs last so long. So we did a rehearsal yesterday on Periscope, and so if you want to watch our rehearsals for these, follow us on Periscope, which is fcain, and it's fun. And we interact, we answer questions, and then we rehearse another episode, and then we answer a bunch of questions. So it's a good time. You could probably still find it if you follow my Periscope right now, and it'll last for about another 30 minutes, and then it'll be destroyed forever. Actually, it will be available forever to all the people who are our patrons on Patreon. That's one of the things we have behind the Patreon wall, is watching those rehearsals. So Once again, I just want to give you all one last reminder to rate, review this on iTunes if you haven't already. That would really, really mean a lot to us. Really. And I want to also say a big shout out, of course, to the WSH crew, which is, of course, the production of this show. These are the great people at the Google Plus space community called WSH crew, and they are the secret Illuminati that make this show happen. They organize the guests, they tell us what to talk about, and they cut us off when we get too deep into their inner workings. So on that note, I think we'll wrap this up. One final thing, which is we're going to have a very, very special guest next week, and I'm not going to say who it is, but you should go ahead and guess, and I think you'll be really pleased if you tune in next week and see who happens to join us on the Weekly Space Hangout. And of course, if that falls through, then I am not left holding the bag, and that's why I'm not being super clear about who it's going to be. So anyway, it's going to be a very special guest. If everything works out, it's going to be awesome. So join us next week. We'll see you all then. Thanks, everyone.
Bye.